Welcome dear students. In this lecture I am starting with problems of magnetic circuit, parallel magnetic circuit. The first problem we have already discussed in the class. This is the second problem. Okay. A magnetic circuit made of mild steel is arranged as shown in figure. The central limb has cross-sectional area of 800 mm square and each of the side limb has cross-sectional area of 500 mm square. So this is the central limb and there will be two parallel limbs for parallel circuit. One is left limb, other is right limb. And the area of these two limbs is given. Central has 800 and side limb has 500 mm square. Central limb is bound with 500 number of turns. Calculate the current required to set up a flux of 1.3 milliweber in the central limb, assuming magnetic leakage negligible. So your aim is to find current you are applying through this circuit. We are applying a value of current through the circuit in order to set up a magnetic flux. Your aim is to find the current through the circuit. The mean length of magnetic paths are given, that is length of central limb 120 mm, air gap 1 mm. Then these two paths is having same length 300 mm. And given that for mild steel, magnetic field intensity is 380 ampere turn per meter to produce a flux density of 1.625 Tesla and 850 ampere turn per meter to produce a flux density of 1.3 Tesla. So take your electrical notebook with you for doing the problem parallelly. So first you read this question once again. So let us see this figure. So this is the figure of a circuit. Okay. Your aim is to find, we are applying a current through this path. So we are going to apply a current through this path. Okay. This is the current we are applying. Let I be the value of current. Okay. Capital I be the value of current. Your aim is to find this current. Okay. And this is the coil having 500 number of turns. How will you find the current? For finding the current, which is the equation we are mainly using, equation equal to MMF equal to F equal to N into I. Okay, number of turns into current through the coil is MMF. So your aim is to find current. So current equal to I equal to total MMF, that is F divided by number of turns N. Will you find a total MMF? Total MMF equal to, what is total MMF? The supply, total EMF, that is total MMF is N into I. N into I. Okay. And apply KVL in this loop. How will you find total MMF in a circuit applying KVL? Either you have to take the path A, F, E, D, A. That is this path A, F, E, D, A. Or take MMF in the path A, B, C, D, A. This path. A, B, C, D, A. Any of two paths you can take for applying the KEL. And the important thing is in each path there should be NI. If you are taking this path, NI is included. If you are taking this path also, NI is included. Okay. So what is the MMF for this path? So MMF of first path, any of the path you can take. I am taking the first path A, F, E, D, A. What are the MMF? MMF Ni equal to, what is the MMF? MMF of AD, that is this path. MMF of AD. We know that this AD is split into two paths, AM plus MD. So MMF of AM plus MMF of MD plus then this portion AFED, MMF of AFED. This is the total MMF of the circuit. MMF AM plus MMF MD plus MMF AFED is the total MMF of the circuit. Next, your aim is to find these each individual MMF. MMF of AFED equal to MMF AM plus MMF MD plus MMF AFED. If you are taking this path, then you can write MMF AM plus MMF MD, that is same. Then MMF ABCD. Okay, so any one path you can take. So you are taking this path. Coming to our slide. So in order to do the problem, this is the total MMF of our circuit. Okay, MMF of AFEDA equal to this total MMF. Next, what are the given datas? In this slide, the given datas are number of turns is given, N equal to 500 given. Then flux linkage, flux phi of the central limb, flux in the central limb. What is the flux in central limb? That is given as in the question. Read the question. The central limb is bound with 500 turns. Calculate the current required to set up a flux of 1.3 milliweber in the central limb. So flux in the central limb is given as 1.3 milliweber. Okay. Next data given, length of the iron path and air gap. Length in the both limbs. Length of both side limbs equal to 300 millimeter. That is 300 into 10 raised to minus 3 meter you have to take. Then length of central limb equal to 120 millimeter. Then length of air gap equal to 1 millimeter. Then area of central limb 800 millimeter square. Then area of side limbs, both are same. It is 500 millimeter square. These are the data given. Okay.